In this video, we're going to take a quick look at the average rate of change. So imagine that I have a function. In this case, I have the function f of x equals x squared minus x minus 2. The graph of that function is here. It's a parabola pointed up. The average rate of change is going to tell us how fast that function is changing from one point to another. That is, on average, how fast the function is changing from one point to another. So when we talk about the average rate of change of a function, we're actually always doing it in regards to specific x values or with regards to specific points. For instance, we might want to find the average rate of change of this function from the point 0, -2 to the point 3, 4. These are two different points that the function passes through. And obviously, when we're traveling on the function from 0, -2 to 3, 4, we go down a bit and then we go up. If we take the rate of change, it's going to differ as we move along this function. But the average rate of change from this point to this one is going to sort of cancel out the dips and the inclines, and it's just going to be a straight shot from point 0, -2 to point 3, 4. So that's going to give me a straight line. And the rate of change of that line is going to be simply the slope of that line. So that's what the average rate of change is doing. It's telling us how fast the function is changing from one point to another on average. And the way we calculate it is we calculate it from 2 points, from point 1 to point 2, by taking the y value of point 2 minus the y value of point 1 and dividing that by the x value of point 2 minus the x value of point 1. Notice that the average rate of change formula is the same formula for the slope of a line through those 2 points. In this case, we can visually see that line. We can also do this algebraically. Let's take the average rate of change from x value of 0 to x value of 3. That's like saying the average rate of change from the point 0, -2 to the point 3, 4. Well, the average rate of change we can calculate by the formula y2 minus y1 divided by x2 minus x1. In this case, that's going to be 4 minus -2. That's the difference in the y values, divided by 3 minus 0. That's the difference in the x values. And that gives me a positive 2. So the average rate of change from x equals 0 to x equals 3 on this function is 2. And that's the slope of the line because we would have had to gone up 6 units and to the right 3 units to go from this point to this point. Now we can do that with any x values. So if I want to find the average rate of change of the function, that same function f of x equals x squared minus x minus 2, from x equals -2 to x equals positive 3, well, when you plug in -2 in the function, you get out a 4. We've already seen that the function goes through the point 3, 4 as well. If I'm trying to find the average rate of change, the difference in y values is going to be 4 minus 4. The difference in x values is going to be 3 minus -2, which gives me a 0 over 5. So the average rate of change from x equals -2 to x equals 3 is 0. We can see that on this graph because -2, 4 is this point here, 3, 4 is this point here. Obviously, our function decreases for a while and then increases, but the amount of decrease and the amount of increase cancel each other out, and the actual change in the function on average is 0. We've just stayed constant on average, even though we haven't stayed constant the entire time. And this shows you that having an average rate of change of 0 does not mean that your function is constant. Let's do one more example. Find the average rate of change of this function from x equals -2 to x equals -1. When I plug in x is -2, we see that the function goes through the point -2, 4. If I plug in x value of -1, we see that the function goes through the point -1, 0. Average rate of change becomes y value of 0.2 minus y value of 0.1 divided by x value of 0.2 minus x value of 0.1. That's going to be 0 minus 4 divided by -1 minus 2, which comes out as -4 over 1, which is -4. Obviously, in this case, we were going from this point here to this point here. On average change, we went down 4 and over 1. This also shows that when our function is decreasing on average, we get a negative average rate of change. When our function is constant on average, we get 0 as the average rate of change. And when our function was increasing on average, we got positive rates of change. So positive average rates of change. This shows the average rate of change in general and how to calculate it. If you want a full lecture, then we'll link a full lecture in the description of this video below.